Hello everyone, welcome back to our course. Next, we are going to introduce classification and representative works of NoSQL. As we can see, NoSQL can be broadly classified into four categories: key-value databases, document-oriented databases, column-based databases, and graph databases. In each class, there are various NoSQL databases in production. And we can pick some of the representative products for each type. Here, you can find a table of introduction to major NoSQL databases. Firstly, key-value type. As widely used in caching scenarios, Redis and Memcached are two famous key-value databases. And the main application is to cache session information, configuration files, and shopping carts, etc. As indicated by its name, key-value databases use key-value pairs as the storage mode, which is usually implemented based on a hash table. The most significant advantage is the high speed of data accessing. But in Redis and Memcached, data is unstructured and is usually treated as string or binary data. So it is not efficient if we need to do complex data analysis. The second one is column-based databases, where the most famous products are HBase and Cassandra. Unlike key-value databases, databases of this type is usually implemented to support log systems or blog platforms. Because now, in column-based databases, there are tables, although the tables are distributed and split according to the so-called column family. Simply speaking, a column family is a family of columns, and it is regarded as the basic physical storage unit. For column-based databases, the pros are fast search and easy distributed expansion. But they do have their drawbacks that column-based databases are not suitable for random update and real-time deletion or update operations. The third one is called document-based database, and the representatives are CouchDB and MongoDB. Databases of this type are also used in log systems, but they can store log information in different modes. And moreover, document-based databases can be used in weak pattern-based data analysis. Here, weak pattern-based means that it does not have a very strict requirement of the data structure, which guarantees the high flexibility. And as indicated by its name, document-based databases use document as their basic data model. We will show you the definition of the document slightly later. And you just need to know that the data model of document-based databases are similar to key-value types, but with much higher flexibility. So it has variable table structures, good extensibility, and suitable for unstructured objects. However, some products do not support transactional operations, so it cannot be used in scenarios with high data consistency demanding, such as money transactions. The last one is graph database, where Neo4j and Infinite Graph are widely used in production. Please note that the graph databases are not for storing graphs. Instead, a graph database uses graph theory as the underpinning, and simply speaking, it uses graph structure as the data model. And a graph is very suitable for storing relationships between individuals, so usually people use graph databases for recommendation engines relational map, and perhaps to build up a knowledge graph in AI applications. As we mentioned before, graph databases use graph theory algorithms to deal with specific domain problems. But it is not applicable to the non-graph field. So from the introduction so far, perhaps you can have further understanding of what we have mentioned before. NoSQL databases are really complicated, and there is never a single one product can meet all your needs at the same time. Alright, and next we will look a little bit deeper at the 4 types so that you can be more familiar with them. The first is a key value database. The basic principle is that there are multiple keys in the database, each of which stores a value. These keys and values are organized through a hash table. Values stored in key values can be of various types, such as simple integer values, Boolean values, and structured data types, such as lists and JSON structures. Key value databases are simple, easy to deploy, and powerful performance when frequently read and write. Key value databases have low data correlation but high performance. However, there are some disadvantages. For example, when only some values are queried or updated, the efficiency is low. It lacks indexing and scanning functions, and it is not suitable for complex query and aggregation. So, as mentioned before, key value databases are applicable to store user information, such as sessions, profiles, parameters, shopping carts, and so on. This information is usually associated with the ID as the key. In this case, the key value database is not a good choice. But key value databases have some inapplicable scenarios as well. For example, it is inapplicable if we need to query by value, because key is the only criteria for data query. Secondly, it is inapplicable if relationships between data need to be stored, because you cannot associate data with 2 or more keys in a key value database. Thirdly, it is inapplicable if we need transaction support, because rollback cannot be performed when a fault occurs in the key value database. The second type is the column-based database. This type of database stores data that is strongly related in the same column family in a clustered manner. For example, if we have a person class, we usually look for their name and age together instead of their salary. In this case, the name and age are placed in one column family and the salary is in another. Below is an example of a table in a column-based database. For each row, there is a row key as the only index, and the data has concepts called column family, which is a family of many fields as columns, like info is a column family, while height and state are known as fields or columns. Likewise, column-based databases have their own applicable scenarios, such as log storage and supporting blog platforms. Meanwhile, they have their own inapplicable scenarios, like Cassandra does not support transactions. And it is difficult to predict how data would be queried at the beginning of the model design. The third type of database is document-based database, which is similar to the key value database mentioned earlier. Here we say it is to store documents in a specific form, and simply speaking, it can be regarded as an upgraded version of the key value database, because the stored content are usually JSON or XML documents, which is very similar to a key value model. Here, we introduce that Each document is a self-contained unit of data, or namely, a collection of data items. Each data item has a name and a corresponding value. Values can be simple data types such as strings, numbers, and dates. In this way, indexes can be created for some fields and some functions of relational databases can be implemented. The characteristic of document-based database is that the data structure is not strict. The table structure is variable but lacks uniform query syntax. It is mainly used in event logs and e-commerce websites. However, it is not suitable for complex transactions. And because of the basic properties, document-oriented databases are applicable in log storage and analysis cases as well. But as we mentioned before, if we need to add transactions on different documents, it is inapplicable. Document-oriented databases do not support inter-document transactions, so it is not a good choice for large commercial banks. The last one is graph database. As indicated by its name, graph databases allow us to store data in graph structures. In the graph, individuals are regarded as vertices, and relationships between individuals are regarded as edges. And here is an example for easy understanding. Because Steve Jobs founded Apple, so the relationship between Apple and Steve Jobs is that Steve Jobs founded Apple. Likewise, the relationship between Next and Steve Jobs is that Steve Jobs founded Next. From its basic property, we can see that graph databases is applicable in some highly relevant data, and it is also a good choice to build up a recommendation engine. Alright, that's all for this chapter. In this chapter, we introduced the classification of NoSQL databases and the definition as well as some basic application scenarios of the 4 types mentioned here. Hope you guys enjoy all the contents in this chapter and see you in the next chapter.